Hello everyone, my name is Siti Nur Azwaliana binti Muhammad Nur Zaini. My matrix number is 2022453064.
Hi, my name is Sharifah Nushafia binti Syed Muhammad Afendi. My student ID is 2022453464.
Assalamualaikum. My name is Fatina Jo binti Muhammad Salihin and my student ID is 2022841588.
Introduction for analysis of function 1. What is a polynomial function? A polynomial function is a function that can be expressed in the form of a polynomial. The definition can be derived from the definition of a polynomial equation. A polynomial is generally represented as px. The highest power of the variable of px is known as its degree. Degree of a polynomial function is very important as it tells us about the behavior of the function px when x becomes very large. The domain of a polynomial function is entire real numbers.
In the problem statement, for the question A, we need to find the x-intercept and y-intercept for the fx given. In x-intercept is when fx equals to 0 and y-intercept is when x equals to 0. Next, for the question B, we need to find the intervals where fx is increasing or decreasing by differentiate the fx given, that is f prime x. Then determine the extremum point. After that, in question C, we need to find the intervals where fx is concave up or concave down by differentiate f prime x that we got in B, then determine the inflection point. Lastly, sketch the graph of fx using all the information we got in A, B, and C.
For the problem solution, I will present how to solve this question.
So from the question, they give fx equals to x in bracket x plus 5 and the power of 2. For the first step, we need to find x-intercept and y-intercept. But before that, we have to expand the function so that it would be easier for us to solve the question. So this is how we will expand the function. And lastly, we will get fx equals to x cubed plus 10x squared plus 25x. So now we can find the x-intercept. We have 2y equals to 0. Then you will get the value of x. For the y-intercept, we need to add 0 in the value of x, then we will get the answer which is y equals to 0. Next, the interval of increasing or decreasing. First and foremost, we need to find the critical points by differentiate fx, and after that we need to equal by 0. Then we will get the critical value. Next, we will draw the test table. Negative 5 and negative 5 over 3 is the critical value. Then between the interval, we use negative 6, negative 4 and 0 for the test value. Next, we will get the sign of f prime x. We will get negative infinity to negative 5 union negative 5 over 3 to infinity as increasing interval and negative 5 to negative 5 over 3 as decreasing. We also can find the minimum and maximum point from the critical value. We need to substitute the critical value into the function of fx. Then we will get negative 5 to 0 as maximum point and negative 5 over 3 to negative 5 over 27 as minimum value. So to find the concavity, we need to use the second derivative test. Then set f prime prime x equals to 0. Then we will find x, which is the inflection value. Next, we need to find inflection point, which is we need to substitute the inflection value into the original function. Then we will get the inflection point, which is negative 10 over 3 to negative 250 over 27. For the test table, we can use it to find the concavity. pick number between the interval for the test value. For the example, -4 and -2. Then we will get the sign of f prime prime x. For the concave up, we get -10/3 to infinity, and concave down is -infinity to -10/3. So for the lastly, to sketch the graph, we need to collect all the information we calculate just now. So this is how I sketch the graph.
Lastly, for the conclusion, we get the first derivative describes change in the direction and the second derivative describes the concavity of function. So, concavity relates to the rate of change of a function derivative. A function is concave up where the derivative f prime is increasing or when f double prime is positive. A function is concave down where the derivative f prime is decreasing or when f double prime is negative. To find the inflection points and intervals of concavity, we must use the second derivative of a function. The point at which f double prime x equal to 0, it is called an inflection point. An inflection point is a point on a curve where the concavity changes from concave up to concave down. That's all from us. Thank you everyone.